In previous lessons, we have learned about similar triangles. Now, this video will involve similar triangles, but I'm going to teach you about a shortcut called the side splitter theorem. When you have a triangle inside of a larger triangle like this, and one side of the smaller triangle is parallel to a side of the larger triangle, that's when the side splitter theorem comes into play. It turns out that these segments, so I have this segment and I have this segment, okay, the upper piece and the lower piece, and I'm going to call this C and I will call this D. According to the side splitter theorem, these segments are proportional. So A over B is going to equal C over D. That is the side splitter theorem. Notice that this segment is not necessarily a mid-segment unless A and B are equal. This is not a mid-segment. All right, but still the sides, these pieces are proportional. Okay, so let's see how that shows up within a problem. So on this particular problem, we're supposed to find this question mark. I'm going to go ahead and call it x. So I've got the 15 and I've got the x. Now, on this side, I'm going to also need two expressions. So this is 4, all right? This little piece right here is 4. What about the other piece? Since I'm told that the whole thing is 14, then that means that the other piece must be 10, right? 14 minus 4. So now I can use the side splitter theorem, and I can say that 10 over 4, all right, this piece over that piece, is equal to 15 over x. So 15 over x. All right, which is just the same thing as I was doing right here. Okay, notice that, let's say I knew that this was x and this was y. I cannot use the x and the y. This is the side splitter theorem. Okay, we are splitting the sides of the large triangle. All right, we are taking the sides of the large triangle and we are splitting them into pieces. We cannot use the parallel sides. You cannot use the x and the y. So in this picture, notice that we're not using the parallel sides. We're using the non-parallel sides. Anyway, this reduces down to 5 over 2 is equal to 15 over x. And then you would do, you would cross multiply. So 5 times x, so we've got 5x. And then 2 times 15, so that's 30. And then if you divide both sides by 5, you come up with x is equal to 6. Similarly, for problem number 2, all right, I'm going to call this x instead of question mark. So I can do x over 18 is equal to 20 over 8. All right, it's like part over part is equal to part over part. Let's see, so I've got x over 18 is equal to, and this would be, both of these are divisible by 4. So this is going to be 5 over 2. So when I cross multiply, I'm going to get 2x is equal to, and then I multiply along this diagonal. So let's see, 5 times 18, that's 90. Then if I divide both sides by 2, that's going to be 45. So x is 45. do we have a mid-segment? Why or why not? We do not have a mid-segment because the segments on either side are not congruent. See how we have a 20 and we have an 8? If this were a mid-segment, these would both be the same, like 20 and 20, or 8 and 8. In other words, this point right here is not a midpoint. And both of these points have to be midpoints if this is going to be a mid-segment. Notice that the side splitter theorem still works even if the lines don't form into a triangle. As long as all three of these lines are parallel. All right? So if all three of these lines are parallel, the side splitter theorem still applies. So if this segment right here is A and if this is B, and if this is C and this is D, then still A over B is going to equal to C over D. They're still proportional segments. Okay, so let's see how that shows up inside of a problem. Okay, let's be careful. I need to remind you of one more thing. Let's talk about what happens when we have a segment that is split up into two pieces, and then we're dealing with parts and we're dealing with the whole. So let's say this whole thing was 10. Okay, imagine that the whole thing was 10. If I told you that this portion over here was 4, guess what the other portion would be? You probably just said 6. All right, because you know that 4 plus 6 is equal to 10. Now, indirectly, what you're doing is to find the missing side over here, you're really subtracting. You're really doing 10 minus 4. All right, you're doing the whole thing minus the part that you already have. Okay, so keep that in mind. Because what if I didn't know that this was 4? So I don't know that that's 4. Okay, I should still put the minus sign back. If I told you that this portion was x, unknown, you could still tell me that the other portion is going to be 10 minus x. All right, that makes sense, right? When this was 4, then this side was 10 minus 4. If this was 2, this side would be 10 minus 2. So if this is x, then this side will be 10 minus x. It's the whole thing minus the part that you already have. So now keep that in mind as you look at problem number 3. Okay, the whole thing is 77. This portion right here, I'm going to call it x. What will be an expression for the other portion? Well, it's going to be 77 minus x. It's going to be the whole thing minus the part that we already have. All right, so that's important. So my two segments are x and 77 minus x. Now I can do the side splitter theorem. So I can do x over 77 minus x is equal to 30 over 25. Part over part is equal to part over part. That's the side splitter theorem. Okay, and it has to be 77 minus x. It can't be x minus 77. So let's reduce at least. So I have x over 77 minus x is equal to, both of these are divisible by 5. So that's going to be 6 over 5. Then I will cross multiply. So if I multiply along this diagonal, that's going to give me 5x. Looking at the other diagonal, all right, I've got 6 times 77 minus x. And I need to do the distributive property. Okay, so let's see. What is 6 times 77? 462. So I've got 462 minus 6x. I want to add 6x to both sides. So that is going to give me 11x is equal to 462. Then I will divide both sides by 11. And that is 42. All right, taking a glance at number 4. Again, I know that the whole thing is 22. So if I call this segment x, the other segment is going to be 22 minus x. It's going to be the whole thing minus the part that I already have. Okay, so now I can do the side splitter theorem. So part over part is going to equal part over part. So I can do 22 minus x over x is going to equal to 5 over, hold up now, I don't know what this other part is. Of course, the other part must be 6 because I just did 11 minus 5. Again, it's going to be the whole thing minus the first part, so that'll be 6. So it'll be 5 over 6. So when I cross multiply, I'm going to do this diagonal. So that'll be 5x is equal to, and I've got the other diagonal, and that's going to be 6 times 22 minus x. So that's 132 minus 6x. It's time to add 6x to both sides. So that is 11x is equal to 132. And then I would divide both sides by 11. That's 12. So, looking at number 5, on both of these sides, I'm given the whole, and then I'm missing one of the parts. So let's do the obvious part first. Here I have 36 as the whole, and then one part is 20. What's the other part going to be? So of course, what I do is I take the 36 and I subtract 20 from that. So that's why the other portion is going to be 16. Okay, 20 plus 16 is 36. But we will do the exact same thing even though we have an expression. All right, we start by taking the whole thing, and then I subtract the part that I already know. And that should give you the missing piece. But in this case, that's all we've got. So we just have to stop. Okay, maybe I can squeeze it in there. Let's see. Can I write it sideways? 45 minus 5x. It's not too bad. So now I can do the side splitter theorem. All right, so part over part is equal to part over part. So, so that's going to be 5x over 45 minus 5x is equal to 20 over 16. Both of these are divisible by 4. So that's going to give me 5x over 45 minus 5x is equal to 5 over 4. And then I will cross multiply. So if I multiply along this diagonal, I'm going to get 20x. If I do the other diagonal, so I've got 5 times 45 minus 5x. And then I need to do the distributive property. So we'll have 20x equals. That's 225. 5 times 5 is 25, so that's 25x. Then you would add 25x to both sides. So that is going to give me 45x is equal to 225. All right, of course, then I will divide both sides by 45. And that is 5. And that is the answer to number 5. Maybe I'll put it way up here. X equals 5. Boom. All right, we're going to work that same magic on number 6. On this side, I already have a part and a part. On this side, I have a part and a whole. So again, the missing part is going to be 28 minus 8. All right, so the whole thing minus the part I already have. But that you can do in your head. And 28 minus 8, that's 20. Obviously. So now I can do part over part is equal to part over part. So that's going to give me 3x minus 5 over 10 is equal to 20 over 8. Both of these are divisible by 4. So that's going to give me 3x minus 5 over 10 is equal to 5 over 2. So now I will cross multiply. All right, so I've got 2 times 3x minus 5 from that diagonal, and from this diagonal I get 50. Okay, distribute. So that's going to give me 6x. Whoops, almost forgot to multiply the 5. That would be a big no-no. All right, so 6x minus 10 is equal to 50. Then I'm going to just add the 10 to both sides. Okay, I'm running out of space, so I've got 6x is equal to 60. And when you divide by 6, you get x is equal to 10. Which again, I just think I'll put it way up here. X is equal to 10. All right, I decided to zoom in. So side splitter once again, part over part is equal to part over part. So that's going to be 6 over 5 is equal to 12 over x minus 1. All right, pretty straightforward. Okay, so let's do our diagonals. So I've got 6 times x minus 1. And then 5 times 12 is 60. So this is going to be 6x minus 6 is equal to 60. Add 6 to both sides. So that gives me 6x is equal to 66. Then when you divide both sides by 6, you get x is equal to 11. Okay, which I think I will just put right here. X is equal to 11. Boom. So that was number 7. Number 8 is going to take a little bit more thought because we have a whole and then we have the missing part. And we have a whole and we have the missing part. So let's start with the easier one. So anytime we have a whole and one part, and we're looking for the other part, we always do the same thing. To find this missing piece, I start with the whole and I subtract the part that I already have. So in this case, that's just going to leave the number 10. But I did the whole minus the part that I already have. So I'm going to do the exact same thing over here. If I want to find this missing piece right here, I need to do the whole minus the part that I already have. But in this case, the whole is 7 plus 14x. And the part that I already have is 22. So I need to do 7 plus 14x minus 22. Because of the x, all I can do is combine like terms. Okay? Negative 22 and a positive 7. You should be able to do this in your head, but just in case you can't, I'm just showing you that you could type it in like this. I'm doing, well, it's probably just better just to do 7 minus 22. Okay, so that will be negative 15. So I've got minus 15. All right, so that should be the missing piece. So here I will just have 14x minus 15. Let me just redo that. I said 14x minus 15. All right, now I can do the side splitter theorem. Okay, part over part is equal to part over part. So I can do, for example, 22 over 14x minus 15 is equal to 10 over 25. Now both of these are divisible by 5. So now I will have 22 over 14x minus 15 is equal to 2 over 5. And then I will go on to cross multiply. So if I do this diagonal, then I'm looking at 2 times 14x minus 15. And then if I do this diagonal, that's 110. So a little distributive property gives me 28x minus 30 is equal to 110. Add 30 to both sides. So I've got 28x is equal to 140. Then you just divide both sides by 28. Five. Okay, and I just feel like writing it up here, so I'm just going to have x equals 5. Kabam. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.